Alrighty, first off the bat, since today's scripting, we're going to want to take a look at our folder structure to make a brand new script in there. So if you remember from before, in the first video I mentioned the asset folder. It automatically populates with the scenes folder, but I created a scripts folder. And that evidently is going to be where we store all our scripts. And to make a new script in Unity, it's actually pretty simple. Just right click, go to create, go to C# script. We're gonna make a script that's gonna move an object. So we're gonna say we'll call this a move object. Sure. So that might just automatically open up. That's fine. That might automatically open up your Visual Studio or whatever file editor you have automatically. Or if it doesn't, you can just highlight over it, double click, and it should open up automatically. Now, you're going to see some already created stuff here. There's this thing called Monobehavior here that's basically marking this class here as a child of the existing API, and that means we can use everything in Unity. Without this Monobehavior, we don't have access to anything. You see how start and update got grayed out because these are just normal functions rather than the inherited functions from Monobehavior. Let's type that in again. My Visual Studio doesn't freeze or crash, so that would be ideal. And we see we're using the Unity engine here. The Unity engine has a lot of stuff in it we can use. We'll go on through. So we have our class move script, move object is what we call it. So we're gonna look at these API calls. So this is a class, and what we want to do with an object. If I go into Unity here, basically what I'm going to want to do is that we'll use this ball as an example. We'll say it starts at a location, and then I just kind of want to make it move down the x-axis for 10 units or something like that until it reaches its start location again. Until it reaches the end location, and then I want it to repeat, respond back here, and then start again. So let's script that. Now, the few things you have to know about scripting in Unity is that, first off, we have this thing called start and update, right? And automatically populates these comments. Start is called before the first frame update. Basically, that means before anything else happens, before anything starts moving, start is called. And that means we can do a lot of initialization in there. And update is called once per frame. So this is code that executes every frame. So making sure that it's good and efficient is key, and we don't want it to do anything. But we're going to be moving our ball in the update function. Now, there's this little diagram here that I have where there's multiple other functionality in Unity. There's an on awake. There's an awake thing like we have in start. There's awake. There's on enable. There's start, which we see here. Fixed update, late update, on disable, and on destroy. So you can see the execution order of these things happening. So that's something to keep in mind in future times where in case we want something to happen before another thing happens in our initialization process. But for right now, these are fine. So there's a couple of ways you can actually move a ball. Now, we're going to do something here. I want to make a public game object. I'm going to call that, we'll just call that object. No, we'll call that moving object, lowercase. So I made this public. That's something important to keep in mind. I made this thing public, this variable public, and I called it of type game object. Now remember, I've been calling everything in our hierarchy as they're basically all types of game objects. Right? This ball here is a game object. This floor here, this parent object, is a game object. Basically, that means that any of these things count as objects, and it's kind of a parent class for a lot of for basically everything. This is basically saying anything can fit in this moving object so long as it is a type of game object. And we know to make that public. Now in start, we can do something. We can do a few things. One, is that you can do moving object is equal to game object dot find and with a name. So if you want to do ball at the very beginning of the thing, this is basically when we're looking at our scene in our hierarchy in the scene, find an object called ball and return that. But this is kind of inefficient. And it's actually, there's something else we can actually do here. If we go into hierarchy, so we want our this ball to be moving, right? I'm gonna remove the rigid body from it for now. And what we're gonna do is that we're gonna look at this thing and we're gonna click add component. And we can search for a move object script. You can see it here. If I click on that, it's added automatically. You can do that via add component, or you can just click on the script here, drag it over, and that automatically adds it as well. Now we see here moving object, there's none in there. So you remember like in our mesh render and in our filter, we had to like put something in there in order for it to work. So we see moving object, there's nothing in there right now. We can actually just place the ball there itself. We can just, the exact same one we just have, we can click on it from the hierarchy, click, drag, and fill it in the slot. So now we have, that's going to basically say that that is the reference that this is going to be looking for. We basically assigned this variable from the inspector. So we don't actually have to assign it anymore in here. Actually, I'll leave that there just in case. And now let's talk about update. So if we want to move an object on the x-axis, and that means that we're going to want to change its position every frame, basically. So let's say I'm going to make a public, let's make it a float distance, right? And make that equal to 10. 10, just for good practice, 10.0.f for a float. And then in update, what we're going to do is that in order to move our objects, we call moving object dot, and you see that there's actually a lot of stuff we have in here. There is the game object itself, which basically gets the game object component of it, which is kind of redundant in this case, but that happens. And we can get the scene, the tag, we can add components to it here. We can compare that the tag of the game object to something else. We can get components in this game object. So say I wanted to get a component, like I wanted to get the transform or the sphere renderer, sure, or the rigid body or something like that. You would just do get component and then put in like rigid body, and that would return a rigid body component. And this, if I change this to sphere collider, that would also return the sphere collider. So that's how you can get components from. You can get access to the reference of a component of a game object like that. But we're not going to do that. Instead, every game object, like I mentioned in the last video, has something called a transform. And the transform is the physical representation of our object in our game world. So our transform has Euler angles, has the forward vector, which, a normalized vector representing the blue axis of the transform in the world space. So basically what it's facing in the forward. It has all these other functionality that we can have, that we can check. And you can get the parent of it, like what is the parent. So if I went back to our floor here, let that compile. If we go back to the floor here, if I put this script on the main floor, the parent of main floor would be this floor object. So there's a lot of things to take in consideration here. And there's a lot of properties in our transform that we can like take a look at, and a bunch of functions that we can check. And you can see like we can rotate it a certain amount, look at all of these things we're going to be looking forward, and we're going to be trying these things out. There's a lot to look at right now, but as we start scripting and looking and do more things, you can get more comfortable and figure out like, oh wow, Unity can do these cool things that I kind of want it to do. It has that functionality. But for now, for moving our ball, we want to check the position of our ball. And now the position contains a lot of different things. It's basically a vector 3. So it's just one vector with an x, y, and z coordinate component to it. So basically we want to get the x, right? And let's store that. So we'll call float cur position x, sure, is equal to this dot x, right? And basically we would do if current position is greater than distance, we'll call a reset function. We'll make a reset function. Oh goodness, Visual Studio. I'll just make it first. So we'll do void reset. So this is a new function I'm actually calling. It's not part of a void reset object. There we go. Void reset object. So I'll just call this here for now. And let's say that we'll reset the object. Else, we're going to say cur position x plus equals 0.4. Just some random, 0.1, sure. Just some random number that we can check easily, or even less than that. So that way we can see it, but it'll start moving a little slowly. And then we'll do moving object.transform.position.x is equal to current position x. And you'll see that that doesn't work. And if you know why, it's because the position value here is a vector 3. You can't easily change it. And I wanted to demonstrate that. So there's some values you can't just straight up change on the fly. But we can work around this. So basically we can just make a new vector 3 with our x value, the new current x, then moving object.transform.position.y, moving object.transform.position.z. So we're basically just using its own values again, and we're just making the position equal to a new vector. Now you could do it with a separate variable, but you can actually just make a new vector with this moving object.transform.position.x plus whatever value you want, and that would work as well. This is just for the sake of brevity. This is just how I'm doing it here. And in our reset object, well, first let's test this out, see that it actually works. So we can see, since we put that script on our ball, we referenced the ball is actually moving until it reaches 10, and then nothing happens because we don't have a value there. We don't have anything in our function call. And we noticed that it was at distance 10, right? And you can see our distance variable here in our move script that got populated now because we made that public. If I were to make this a private float, if I go back here in Unity, check it, you'll see that this distance thing here actually is gone now because it's private. We can't access it in editor. So we're going to make that public. And what we're going to say, we do want to access it. Now you can actually change the distance here too. So it was 10 in the script, and we set it to 10, but you can actually change it to 20, and it will use the value you set in the script. So actually, we'll make that actually just 2. So you'll see it's not going to move very much at all until it reaches 2, and then it stops, just like that. All right. So we have our ball in our script, but we have no way of resetting our object. Now I'm going to show you guys something else that we can do. So there's a few things of note. One, this game object moving object, that's good and well, and you're going to want some scripts that have that. But if you're placing a script on the object itself, you don't actually need to put in the game object, moving object. So for example, in start, moving object is just going to be equal to this value called game object, and that's a property of Monobehavior. Basically, it's meaning that whatever game object this script is placed on, that is the game object this is referencing. So I'm gonna make this private. So we can no longer change that. And then we'll see here that it will still actually work without that there. Represents the ball just fine. So we have that now. We don't even need to drag it in because it's referencing the script that it's on. For example, if I were to put this script on the plane, the moving plane, on the main floor here, you can see the floor is actually going to move as well to a distance of 10. These scripts are independent. A script is not runnable unless it is in the inspector, or at least unless it is attached to a game object. That's how monobehavior works. That means it's a reference to the scene. There are some ways around this, but that's more advanced material. For now, just know that if you want a script to actually work, it needs to be attached to some game object in your scene. All right. So what we want to do now is reset the object, right? So what we can do, similar to what we did before, we'll do a public game object, and we'll call that our starting point, right? And then a reset object, what we're just going to do is that we're going to make moving object is equal to starting point dot position, transform dot position, moving object dot transform dot position. So we're basically setting the position of our moving object, which is a reference. So this moving object is holding a reference to our game object, to our OG, the object that we are moving, that the script is on. Moving object is holding a reference to that. So whenever we change a value of it in this variable, it's actually going to change the object itself. So in reset object, we're just going to move the starting point there. And now let's look in Unity. So we need a starting point now, right? So I'm going to make an empty. I'm just going to call this starting point. There's nothing in there except for the transform. And I'm going to make this, what is it? I'll make this 0, 5, 0, right? And then ball, we'll just make that a clean 5. So now starting point is none. There's nothing in there. And if there is none in the game object, that's just equal to null, right? And we don't want to access anything in null. So I'm going to drag starting point there. I'm going to click play. And you'll see it pops back. And you'll see in our console, we actually are receiving an error because in main floor it's trying to call reset, but we never actually set up the starting point. And this is where Unity can come in handy because we can set things on the fly. So if I put starting point there, you'll see that the plane actually has that at the starting point. You can change things on the fly. It's pretty spectacular. So I change it to entrance floor. Once it gets there to 10, it's gonna move there. And that's really simple stuff that we just did, but there's a lot of different ways we could have done that, right? And what's crazy is that what you can actually do is I'm going to make another thing here, and I'm going to call this object mover, right? And if I add a component here, if I add the move object component script there, I'm going to remove move object from here. I'm also going to remove it from main floor. We don't need that anymore. So remember from before that this location, the transform of this game object doesn't matter. We just want the script to be called. So what we can do, instead of just adding a script for moving an object onto an object itself, the one we want to be moving, what we can do is actually just make this public, right? Comment this. And then if I go here, I put the ball as the thing we want to move, and then that's not the right one. If I make ball is the thing we want to move and make our starting point the starting point, right? In a distance of 5. The ball will still go even though it doesn't have the script on it anymore, because this script is the one that's calling all the functionality. It's isolated from the ball, and we can actually make this moving object to anything else. We can make that the main floor if I drag that in. That's going to move instead. Bring the ball back to it. That's going to move. I can move the floor away so you can see. There we go. And that is the kind of the powerful thing of scripting. It doesn't have to be placed. A script does not have to be placed on an object unless it is important to that object. And that's everything. That's all the basic stuff that I wanted to show in Unity. There's a lot of, you can see now, there's a lot of things we can do. And I just wanted to show all the different things that you can, crazy different things you can do in Unity. In the next part, we're actually going to be making a few scripts, and then they're going to be a lot more straightforward, and we're going to be using things. I'm going to explain why I'm doing things the way I'm doing. But that is basically all I wanted to show for the day. All right. See you guys in the next part.